And which of the following particle diagrams best represents the products when 4 molecules of H2O2, you might want to write that down somewhere, 4 molecules of H2O2 decompose into water and oxygen gas. So again, I know this isn't ideal because it's a big question, it doesn't fit really, so let me zoom in a little bit here. So that's what they give you. So it says 4 molecules of H2O2 decompose into water and oxygen gas. Which best represents? A, B, C, D. Hydrogen is the shaded one, it's little. Oxygen is not shaded, it's big. So, is that good enough? Can you see them?
Yes, sir.
Okay.
Well, you do, like, are you waiting for us to answer?
Yeah. Well, I'm assuming it's going to take you at least a minute or so.
This reminded me of Remember, so I can't, like, all this new replacement, it's been a while.
Okay. So, I think I got rid of that sheet. I had a sheet we were going to do in lab. I think I got rid of it. I did.
It decomposes into water, so it can't be air.
Where are you writing that?
Okay.
Trying to figure out the best way.
It decomposes into water, so it can't be air.
You guys ready to do number 2?
Yeah.
Yes, sir.
So we'll just go over 1 and 2 at the same time.
Wait. Okay.
You guys ready?
Yeah.
I'm gonna like lose my mind right now. Sorry guys.
I start writing your.
There you go. Number 2.
It's down.
Is there, like,
26.
top stuff we're supposed to read?
No, that's it. Mass is carbon, hydrogen.
H5, H6, H6.
Reagan, I'm gonna write down all the reaction types on like a cheat sheet using like A, B, C, D stuff, and then you can use it to help. Is that good?
Yeah.
Yeah. Feel free to talk to each other.
12 could go to 6. 42. 3 would do what? 12 times 36. 30 plus 6 is 42. 42.
But it's massive. One's massive carbon, one's massive hydrogen.
36
Split off.
plus 70. Yeah, it's 40. 84. That was 42 times 84.
Oh, wait, it's nuclear, it's just two.
McCoy.
Yeah.
What is an electrolyte? How can anything with the boiling point?
42 times 2.
Colligative properties. Depends on concentration. Add a solute, boiling point goes up. Add a solute, freezing point goes down. So, here we go, real quick. This is actually good for you guys, but you don't need to listen to me. So, if you have if you have an electrolyte like salt, because it conducts electricity in water, that's what electrolyte means. When you put it in water, you actually get 2 moles. So if you have 1 mole of NaCl, you actually get 2 moles
I'm so confused.
of particles. A non-electrolyte, like let me try and think of some more simple examples. C2H6, if you put that in water, it will stay C2H6. It won't break apart. So 1 mole of this produces 1 mole in water. So 1 mole of an electrolyte produces more moles of particles. That's colligative properties, depends on concentration. This has a higher concentration than this, so this will have a higher boiling point, lower freezing point. Does that make sense? So electrolytes always affect the concentration more than a non-electrolyte. All right, you good?
Yeah.
Okay. I should have this first here one. Aha. They have answers, so I don't have have to sit here and figure it out.
I don't-
Okay. 1 is D and 2 is B. Let me back out of here. What's the where's my thing? There it is. Alright, so what they say for 1?
D.
1 is D. Yeah, because these Mickey Mouse, this is water and this is O2. So when H2O2 decomposes, that's what it produces, water and oxygen gas, so that's the only option. That one actually was pretty easy. The only one other, if you were to pick one, like the good wrong answer would be this, because you know water, but then you're picking the wrong one. That's the oxygen, or hydrogen symbol. You want oxygen. Alright, number 2. See, some questions will be easy. This first.
There was not one.
This is, I'm gonna lose my mind. Sorry, guys.
The next page will just be.
Okay. Alright. Okay. So what they say the answer was? B. Sample B. The masses of carbon and hydrogen in samples of 4 pure hydrocarbon given above. Hydrocarbon in sample has the same empirical formula as propene, C3H6. Alright, who got it right? Oh, everybody. Alright, so why is it that? How many carbons is that?
That is double what's in the solution below, I think.
What does empirical mean?
6.
Reduced, right? Yeah. So, so 6 times 12 is 72. So you have C6, and then this is H12. C6H12 reduces to C3H6. Alright, okay. Alright, moving on. You know, this isn't working out because these questions are so big, but
Just
Just
your
read
letter.
screen over.
Why don't you open the screen up with water?
it's because I had to move it and I'm getting less.
You didn't have to move the screen.
Just take the Merry
It's
Christmas.
because of this
Just
Christmas
move
thing.
it.
Just take it down.
It's not mine, take it out.
Move it to the other
Taylor's.
side.
Oh, so take it down.
That'd be funny if I took just hers down and no one else's, and she went in tomorrow and stabbed me in the face.
She would not know.
You should
this.
never notice.
She would never know. Unless
Well,
she
now
watches
it's
this video.
All right, here we go.
She's not gonna watch it.
Go ahead, do number 3.
Can you read to us?
3 substances were studied in a lab with single laboratory. So the data in the table above were collected based on the data which in the comment shows the type of bonding in each substance.
Alright, that first one's high.
Basically, they give you the properties, and then you're supposed to figure out bonding. This is a great question.
So I don't think. And then why is it gonna be molecular? This very well.
Network ionic.
I can zoom in more because you don't
Oh,
even
you're
need
good.
the reading here.
It's
sure?
CD.
You can see I was like, it's
Oh, I didn't even
conducts
read that. I
solid
didn't even
phase.
get that
It's
far
just
yet.
Metallic. Down to the middle.
Yeah.
Wait, are these
Okay.
like? Why are these questions so easy?
Yeah, these are like regions.
Does that mean
This is
our
actually a
test's
reading
gonna be
test.
like
The beginning
really hard?
of the test usually isn't that bad.
Don't they usually like if one
Keep it
test,
open.
like if last year's test was really easy, then next year's will be really hard?
I don't think so.
So that's how
So
they.
yeah, no one cares.
Do we have the hard test?
All right, what do you guys think?
They conduct electricity.
What do you think?
D.
D. Yeah. There is D. All right.
That's
Let's real quick talk about what holds these things together. What holds network covalence? What type of bonds? Not forces of attraction, bonds. So I'm not talking dipole, I'm not talking about induced dipole or hydrogen bonding, all that. I'm not trying to trick you here. It's right. Covalent. So it's covalent bonds.
Oh.
Okay? But why are these special? How come these are way stronger than anybody else? What they don't have this.
Forces.
Well, they don't have any forces. They don't have any forces at all. All atoms are covalently bonded. There's no forces. Molecular has covalent bonds, but between one molecule and another, what's between them? Weak dispersion usually. Could be dipole. So molecular, they have weak forces of attraction. Dispersion, dipole, induced dipole. Alright? So those are the forces that are significantly weaker than the bonds that hold this together. This is kind of confusing. So it's not really a bond. It's just a super strong force that we call a bond. What do all positive, negative attractions, what are they called? Two names for it. Electrostatic's one, but the one I really want you to use, Coulombic, right? So ionic uses Coulombic forces, which is, because it's so strong, they say ionic bond. Metallic also uses Coulombic. What's the difference between metallic and ionic? Metals.
Metallic conductors, so.
How are they put together? What makes up a metallic crystal?
Metal.
Metals.
Yes.
It's
Okay.
Is it like a P?
Yes, it's metal cation, so like Cu plus 2, Na plus 1, Zn plus 2, whatever, surrounded by those mobile electrons. So yeah, metals conduct as a solid because of that. All right, and remember that whole band theory, where there's, and just because you told me it made sense, I'll just keep going back to the loft idea. So like one electron kind of goes up on the loft, creating like a hole or a space, so the other one starts shifting. That creates movement. That's why electricity can flow. You have the conduction zone and the valence band. So anyways, metallic conducts as a solid because of those free moving electrons. Ionics do not, because it's a positive cation, negative anion that are attracted, so they're rigid. They don't have anything moving in the solid phase, therefore they can't conduct. They can conduct dissolving water or as a liquid. Types of network covalent. Diamond, buckyball. You gotta remember more than that.
Which ones did we say?
Silicon.
Silicon,
Is it
just straight up
SiO2?
Si,
Is it
SiO2?
SiO2, SiC, and germanium. Those, and did you say graphite?
Yeah.
Okay. Real quick here, ionic. KF or CaO? Who's gonna have a higher lattice energy? Who's stronger?
CaO.
CaO, very good. Why? Two
More
reasons.
electrons and stronger Coulombic force.
It's stronger Coulombic force, but why? In terms of, I wonder how they would ask that. Well, I just want to leave it open-ended. There's two things that affect Coulombic, but we'll just go over that.
Radius too.
Yeah, how far away the charges are from each other, right? So the smaller the radius, the closer they are, that's better.
It's the magnitude charges.
And the magnitude, right? So Ca is +2, O is -2. They're both actually smaller because they lose and gain more electron. Oh, actually, O -2 might be slightly bigger than F minus because F has 9 protons. But Ca +2 is smaller than K plus. So the way that would happen here is they would give you CaO, and then they would give you the ion or lattice energy, Kf lattice energy. Then they ask you to explain why is one higher than the other. Coulombic force is stronger. They might make you talk about magnitude of charge or radius. But so the higher the charge, +2, +3, -2, -3, and the smaller the radius, the stronger the Coulombic force. Just because that crystal packs together better. All right. This isn't really working out for me here. Every question is humongous. Okay. So there's that.
It's like a whole page.
Yeah, it is like half a page, so it's like very hard to do it this way. All right, so you got butanol, pentane, propanoic acid. So this is why Friday, I was telling Skylar and Chi-Chi, Friday in class, I'm gonna just zip through kind of all the reagents, organic stuff, functional groups, hydrocarbons, just the basic stuff you need to know, just so this question doesn't become stressful. So like if you remember, okay, that's a functional group, this doesn't have one, that's just a hydrocarbon, that has a functional group. If you at least know that, you feel more comfortable, then you can answer the question it's asking. Alright, so I'll just kind of have to do this with you here. Based on the information in the table, which of the compounds has the highest boiling point and why? So out of these three, you have butanol, pentane, and propanoic acid. Molar mass 74, 72.15, 72.10. So these are very close, that's a little bit higher. Which one would have the highest boiling point and why? So again, it's hard to kind of get all this up here at the same time for you. A says butanol, because it can form intermolecular hydrogen bonds. B says pentane because it has the longest carbon chain. C says pentane because it has the most CH bonds. And D says propanoic acid because it can form intermolecular hydrogen bonds. So, is it butanol because it can do hydrogen bonding? Is it pentane because it's long? Is it pentane because it has more CH bonds? Or is it propanoic acid because it has hydrogen bonding? That's basically the four options. Alright, since we're doing it together, what do you guys think? Yeah, I would go with D, and we would all be right. 4 is D. Why can't, this is good. This is why I like doing practice problems, because it makes me think of other things. Why can't this one? I would expect this one actually might have the lowest boiling point. Why? Yeah, usually more surface area means stronger forces. But, is that what you meant? Or less surface area?
I don't know.
Okay. This doesn't have anything but C's and H's. It's a hydrocarbon. This one has oxygen, which increases the electronegativity on this side of it. So this might be more polar because of that reason. This definitely would be the strongest because of the hydrogen bonding. How come this can't do hydrogen bonding? Right. The H isn't bonded to an N or F. Right. So molar mass does also play a role. If this was a short answer question, if you didn't say hydrogen bonding, you could say a greater molar mass means what force would increase? You said it earlier with more electrons. This would have more electrons. Actually, would it? Typically, the larger it is, the more electrons. I don't know. 1, 2, 3, 4, 5, 6, 12. So what's that? How many electrons? That's 30 electrons right here.
Yeah.
30 and 12 is what? 42. 8, 8, 16, 17, 18, 19, 20, 22. And then 22 and 18 is what? 40? Yeah. So, alright, that wouldn't work. But sometimes I'm trying to just think of things they could ask. Usually, if it's if they all have dispersion, so if this didn't have hydrogen bonding and they all were nonpolar and they all used dispersion, the bigger one would have stronger forces because it would have more electrons creating more temporary dipoles or induced dipoles. So that's something related to this question. All right. Next. All right, that's better.
So this is a question I asked one more and then see how it's open. Because I have the lowest rated point because it's not actually more than that. That isn't.
So again, not to be ridiculous, colligative properties depends on concentration. What does that mean? The higher the concentration, the more it affects the boiling point freezing point. So the higher the concentration, the higher the boiling point, the lower the freezing point.
So that means the one moment is the lower amount of water.
Very good, right, because that would be more concentrated. Does that make sense to you? You guys look like you're ready. What do you guys got? C. Let's see. Yep, C. Alright, good. Do I need to go over it? Oh no, but this is a great trick question. Let me find out lower pressure and predicted. Sometimes on the AP test, they give you a question that is testing this knowledge, and they'll give you a chart. I can't just make this stuff up on the fly, I'm sorry. But they'll give you a chart, and it's like the pressure if you use the calculations or PVN and RT, it should be like 2 ATM. But one choice would be less than 2 ATM. And they don't, this is not told anywhere, it's not explained, and the answer is actually less than 2 ATM because of this reason. So just be careful. Any gas question, remember, ideally they should exert whatever the calculation gives you, but in real life they probably won't because they are attracted to each other. So that's just a good thing to remember. Here we go. Alright, well, we'll do it together. Alright. So we got vessel 1, we got vessel 2. Now, the black are positive ions, the white negative, and then water molecules are not shown. Okay? It says equal volumes of solutions in 2 different vessels are represented above. If the solution represented in vessel 1 is KClAQ, then the solution represented in vessel 2 could be an aqueous solution of. So it says you have equal volume, so whenever I read that, I always just think 1 liter. So it just helps me make up a number in my head. When I'm doing these, I say, alright, there's a liter, they don't have the water, whatever. So there's a liter in here. They're telling me this is KCl. They want to know vessel 2 could be a solution of, and I'll bring that back down. So KCl with the same molarity as vessel 1, KCl with twice the molarity of vessel 1, CaCl2 with the same molarity of vessel 1, CaCl2 with twice the molarity. So our options here are the same molarity for A and C, except A is KCl, C is CaCl2, B is twice the molarity, D is twice the molarity, and it's KCl versus CaCl2. So again, I know this is kind of hard to do it this way. That's all we got right now. So do we think this is KCl or CaCl2? That's where I would go first, figuring out, all right, is it KCl or CaCl2? Then I can eliminate 2 answers. Then I would figure out, okay, is this molarity equal to this, or is it twice that? So I'll stop talking for a minute. And then I'll cheat.
When it says under which conditions a gas is most soluble in water, does that mean is that kind of like acting like ideal gases with high temp or low pressure?
So if you want a real gas like helium and hydrogen to behave most like an ideal, which means expand, high temp, low pressure will allow them to do that. But this question's asking, how do you take a gas and force it to stay down in a solution? So think of soda. What do we do to it? Where do you keep? How do you keep soda fresh? And that's your answer. Remember the syringe?
So it'd be high pressure, low temperature.
Very good, right. That's how they huddle together like penguins or goats. Sheep or humans. If there's a bunch of humans in a field and it's freezing, they would huddle together. I would think so.
I know, it's like pretty feet, I'm not like.
What do you guys think?
You do the letters, but.
Oh, want me to go back? Let me give you choices again. So A, KCl same molarity. B, KCl twice the molarity. C, CaCl2 twice same molarity. And D, CaCl2 with twice the molarity. So first, hold it. Do we think it's KCl or CaCl2? Good. So it's got to be C or D. That's good. You're right. It's one of those.
Is it D?
It is D. How do you know?
Because there's
Whoop.
many left.
Twice as many particles in the same amount of solution. That's twice the molarity. Does that make sense to everybody? How do we know it's CaCl2?
That's
The
right.
white ones are not proportional.
It's been an interesting day. All right. Say it again, Liz.
The white ones are not.
Right. It's not a 1-to-1 ratio, so it's 2-to-1. Right. Very good. Okay.
Are you still leaving early?
Yeah. What is? Yeah. We'll do one more problem. Ah, here we go. Here's a fun. This is a hard problem. We'll end with a hard one.
All the math is
Alright, McCoy, I need your help.
I mean, the first 6
It's titrated with
That's good. You get momentum and confidence.
Well, not
Then
anymore.
you
I started to see
You're like, no,
like
you're like,
hers and you're like,
salt and sodium in water, and I looked at this and I got these two, like.
So what does that mean?
These,
What does that mean?
what
Does it mean it will dissolve or not dissolve? Not. Right. So we're looking for out of these 4, which one's inside?
It's biology.
Yeah, so did I start off right or am I completely wrong?
So these 2 actually dissolve.
No,
They are very side. Here's one. Group 1 ions. Li plus and Rb plus 1. They are in group 1, so they dissolve no matter who the bond is.
split up the age
Now I would look at this.
and then they go, this is just
Okay.
basic acid.
All these
It's like
ions
a regular
dissolve
acid
in water
base,
very
right?
well. All these ions.
Got
I think.
These don't
Right?
dissolve.
I don't think they're.
H,
If
yeah,
the
but you
body
form
is
water.
acidic.
So H plus would form water.
These do
You
dissolve.
left with weak.
So for example,
You get rest of the acid, and then you have
ABI
your salt left.
will not dissolve, but NaI will.
I'm gonna go with
NA is not going to accept.
Good
That
night.
make some sense? I mean, I did it quickly.
Yeah, I was never taught how to read it, so I just kinda went as is.
Alright, skip that one. Talk to me
These two,
tomorrow.
and that's it.
Alright, yeah, let's do
A
just
would
one
make
at
sense
some
if you,
point.
if it just wants to.
So I just gotta finish this and I gotta go.
No, but you have to start.
So, but are you doing better? It seems like it.
Start dissociating, right? Like they wouldn't start.
Yeah, like I feel like.
Thinking
I
Alright, so 20 ml sample of acetic acid. You got 0.5 molar of this, 0.5 molar of NaOH. So this is a strong base, weak acid titration. That's important to just be aware of. Which of the following represents species that react and the species produced in the reaction? Okay. It's safe to say, I hope you understand that A is not correct.
You're just gonna get rid of it.
Why?
There's no.
Unless you just.
There's no.
Is the NA doesn't matter.
When is this true?
You know what I mean?
Alright, see you, Reagan. When do you have H plus plus OH minus makes water? I'll just cut to the chase here. When both of these are strong. Like HCl and NaOH, that's what happens. Okay? Because the Cl minus and Na plus float around and do nothing. So that's strong and strong. So A is out. Alright? So now we're down to B, C, and D.
I think
The first thing I look for in these questions is water. They all have water, so that really wouldn't help. I'm just telling you, that's what I think. All right, whatever one. Sometimes they give you an easy one, like they don't have water as a product. So obviously that's wrong. This is the key right here, in my opinion. Species that react.
NA wouldn't react, right? It's gotta be C.
It is C. Na plus is a spectator ion. It doesn't do anything. So really, when you mix these two, all you're reacting is the weak acid. Now, stay with me. Just give me like 30 more seconds. This, remember, is 95% of this acid stays together. Only 5% of it dissociates. This dissociates 100%. So the OH minus really is what reacts, and so is this molecule. So only those two react, producing a strong conjugate base, which is why the pH of this at the endpoint would be like a 9. Because it's a weak base, weak acid, strong base, because your conjugate base would still be present. And hopefully that rings a bell. So that's why it's C. Alright. Good. Good stuff.